Okay, so today we're going to talk about the Pythagorean Theorem and its converse. So the Pythagorean Theorem simply says, in a right triangle, the sum of the squares of the measures of the legs equals the square of the measure of the hypotenuse. So if you know that you have a right triangle, then you can simply say that c squared equals a squared plus b squared. We've got our triangle here labeled with the red side A, blue side B, and then the hypotenuse is C. Now, another way that you can think of this, and this is kind of how I'll think of it most of the time, is that hypotenuse squared equals leg squared plus leg squared. And the thing that you really want to remember is that C, the hypotenuse, is always the longest side. That's very important to remember. That lets you know which one's the hypotenuse and which ones are the legs if you don't have a picture. So a couple of examples are, I've got this example 1 where I want to find the value of x. We're going to, for our purposes, for the most part, we're going to have numbers that we round to the nearest tenth or to the nearest hundredth. You just want to pay attention to that. So if I look at this picture, I can label leg, hypotenuse. It doesn't matter which one really is A or which one is B. They're both legs of the triangle, so we're just going to label them as legs. So I've got hypotenuse squared equals leg squared plus leg squared. X squared equals 2 squared plus 6 squared. And so now you can do this a couple of different ways. You can type that into Desmos. It's not exactly what I wanted to do, but you can type this into. Okay, now. All right. So we can say x squared equals 2 squared plus 6 squared. And when you do this, you get 2 lines here. You get one over here on your left-hand side that's going to be a negative number, and you get one on the right-hand side that's going to be a positive number. And so how do you know which one is correct? Well, we're in geometry. And in geometry, we want to measure stuff. And in real life, does it make any sense that you would measure a -6? No, you couldn't do that. That means if you've got a -6 in math and you have to assign some sort of value to it, then that means that you're 1, falling, 2, you're below the ground, like you're in the earth below the ground in a hole, or that you're over on the left-hand side. But when you measure something, you don't actually have anything negative that you can remember because that's below 0. And you physically can't measure something below 0 in a physical sense. So we're going to take the positive answer. So x will equal 6.3. I'm going to round it to the nearest tenth. All right, my next problem, pretty much the same. I've got a leg and the hypotenuse. So hypotenuse squared equals leg squared plus leg squared. Uh-oh, I flipped the page, not meaning to. So again, I'm going to substitute the values. X squared is 4 squared plus 8 squared. Now I'm going to go over here and I'm going to say x squared equals 4 squared plus 8 squared. Again, I got that negative answer and I got the positive answer. I'm in geometry, I'm going with the positives. And this one would be 8.9. All right, we got a couple more examples, except now we got these funny looking radicals. That's okay. They're just a number. They look different, but they're still just a number. So now I've got hypotenuse, leg, and leg. So hypotenuse squared equals leg squared plus leg squared. Hypotenuse is 11 squared. My one leg is x squared. And then since I've got this radical, I got to use some parentheses. Okay? Same thing. I'm going to type this in. 11. Well, 11 squared equals x squared plus, now remember the parentheses, a negative and a positive, and then that is x equals 9.2. And now the next one, I'm going to work out a little bit more by hand just so that you can see what that's like. So this would be a leg, and the hypotenuse. Hypotenuse is always across from that right angle. So hypotenuse squared equals leg squared plus leg squared. So if I use parentheses, all right, so this stays as an x squared. I can't do much with that. 7 squared is 7 times 7, and that's going to be 49. All right, 145 is inside the radical. And I don't know if you remember from Algebra 1, but when you have that radical, that square root symbol, and you have this square on the outside, these two things pretty much cancel each other, and what you're left with is 145. Now, if you remember, you can type that in. That way you don't have to type in the radical. That makes it a little bit easier for you. And you end up with, on the positive side, x equals 9.8. All right? So the converse of the Pythagorean theorem says, if the sum of the squares of the lengths of two sides of a triangle is equal to the square of the length of the third side, then it is a right triangle. So in all of the examples that we've done so far, we knew we had a right triangle. In this case, we don't necessarily know that our triangle is a right triangle, but we suspect that it is. So when we look at these pictures, or when we look at the values we're given, we want to think, okay, if this is a right triangle, then it makes sense for this side to be the hypotenuse, because why? It's the biggest or the longest number. And so that would indicate it was the hypotenuse. And if it fits the formula we've been using, then we can say for a fact it is a right triangle. So how do these examples work? In these examples, notice I don't have my little corner marked as a right angle. I suspect this would be a triangle, a right triangle. And I suspect that right there that I've circled would be the corner, the 90-degree corner. I don't know for certain until I check it out. So, if I'm looking at this picture, this for example 6, 14 would be my hypotenuse. And then these other two sides would be legs. So hypotenuse squared, I'm not going to write down that formula anymore. I think you guys pretty much know it by now. And then I have to square that whole thing. So I want to make sure that I'm using parentheses. If I'm not using parentheses, I'm going to mess up. So now there's nothing to solve for here. So I'm just going to find out what 14 squared is. It's 196. And now I want to see if 6 squared plus 4 radical 10, put my parenthesis, and I want to square that. That's 196. And since these two sides are equal to each other, then yes, this is a right triangle. All right, my next example, same thing here. If I'm looking at this sketch, I would assume this is the hypotenuse, and this is the leg, and this is the leg. So again, got a radical, so I got to use parentheses. I got a radical over here, so I got to use parentheses over there. All right, let's clear this out. I want to know what this one side is when I square it. It's 257. Yes, I could have just done that by canceling out, but just to show you in the calculator how it works, I want to type it in as well. So 16 squared plus, got to use parentheses because I've got a radical, $288. All right, so this is no. This is not a right triangle. 2 more examples, and we're going to stop for today. Now, in these 2 examples, I do not have a picture. So how do I know which number is bigger? I don't know what 4 radical 5 is. So let's type it in. What is that? 4 radical 5. That's 8.94. All right, this is 8.94. So that means that it's the biggest number. So this is hypotenuse, this is leg, and this is leg. So now I can use my formula. If this is a right triangle, that would be the hypotenuse, I should say. All right, so let's put some parentheses and square it, and I get 80. And now 4 squared plus 8 squared is also 80. So yes, this is a right triangle. And one more example. Oh my goodness, I've got 2 radicals, and I don't know what either one of those are as a decimal. That's just not a piece of information that I carry around. So the square root of 82 was 9 something. And square root 146 is 12 something. So that means this would be the hypotenuse, this would be a leg, and this would be a leg. So using my formula, All right, this would be 146. I'm just going to do that one in my head. And now I'm going to go over here. Plus. Oh, I don't really need to use that. I could, but I don't need to. 98. So no, not a right triangle. All right, so we're stopping notes for today. Go work on your assignment.